Okay, as the slide says, as my shirt says, Andy Dustan, I'm the Programme Manager for the Lake Victoria Water Hyacinth project. As Jeff has also said, I am a witness novice. In fact, 3 months ago I was a witness virgin, but I've broken that barrier. I'm now a witness novice. So when we get to the end, if you have any questions about witness, go easy on me. If you want to talk to me about anything else on the project, then you can throw knives at me, do what you want, and I'll try and answer all those questions. But I hope that by the time I've gone through talking about the project, you will get an understanding how we think witness will help us, not just in our early startup phase where we are now, but right the way through ultimately to the end goal, which will be a very profitable but also a game-changing business for the lives of people in Africa. I'm passionate about it, as Jeff said. I was actually tending an allotment 2 or 3 months ago, and one of the directors rang me up, Andrew Cranfield, and he said, Andy, I've got a bit of an interesting project you might be, having a chat with me about. And I went and saw him, we sat down, we spoke about it, and I became enthusiastic, and I've come on board to help them get the project up and running and get it into Africa, whereupon then I might bail out, I might carry on, it will depend on how I particularly feel. So I'm quite passionate about it. The way I'm going to take you through the project is, first we'll have a geography lesson, but I think most of you can make the connection, Lake Victoria, Africa. We'll then do a bit of sociology, about the challenges to the people that are in and around Africa. Got to do a bit of the marketing, Aquatractor, who are we, what are we trying to do. Then we'll get down and dirty into the project itself, and then we'll get into the noughts and ones of the software and where simulation is going to help us, both at the start and continually through. I'll do a summary at the end, and hopefully, maybe if there is enough time, I might recount an interesting story about wandering mics and presentations, but I doubt we'll have time for that. But I'll also leave you with a bit of a video, just to sort of hopefully stimulate some possible conversations. So, location, Lake Victoria, freshwater lake in Africa. It's, as it says, 3 times the size of Wales. That gives you an idea of just how big we're talking about. 68,000 square kilometres. The area that we're going to be working in is top right. It's the Kenyan side of Lake Victoria, and in particular we're going to be based in the Winam Gulf area. Winam Gulf, there we go. Kisumu is the port where we're going to be setting up our operations. The Winam Gulf is about the size of Surrey, so it's not a small place, and we're going to be on the water, so it's not actually going to be on your little canal. It's like going across a channel and beyond. It's also the fastest growing population, rural population, the lakeside around Lake Victoria Basin in general, and also around the Kisumu Kenyan side. In the context of the project, there are 5 areas I want to talk about. The first one is power. Kenya cannot supply the demand for electricity and gas. It has a very fragile power grid. Power outages are almost regular, daily occurrences, and that's particular in the outlying areas. In the major cities, of course, it's probably quite stable, but certainly out in the lakeside areas around Kisumu, power outages are the norm, not necessarily the infrequent thing. Every country has a problem with waste, and Kenya and Kisumu area is not immune from that. There's 2 types of waste that they have a problem with. The first one is the classic municipal waste. What do we do with it? How do we deal with it? And the second one is that within the Kisumu area, there are major sugarcane plantations, and they generate a huge amount of waste called bagasse in their processing of sugarcane. They also have rice areas, rice growing areas, and that produces a huge amount of waste called rice husks. Today they have no way of disposing of that in a sort of an environmentally and an efficient way. So consequently, most of the time the waste is just left to pile up and rot, or they will just burn it. So they've got a big problem there with waste. Apart from the big major growers of rice and sugarcane, most other farmers in that particular area around the lakeside are very broadly subsistence farmers and above, small farmers. And because fertiliser is not readily produced in the area, they have to import it. So therefore the fertiliser costs are extremely high. So the vast majority of the farmers don't use fertiliser. So the soil is generally poor. They can't afford to buy in the fertiliser. So generally their crop yields are quite low. So they just get by, basically, on the agriculture side. And interesting, as a consequence of the power grid problem, most people in the lakeside area there actually use charcoal fires for cooking. Charcoal, big CO2 polluter, burning charcoal, and also deforestation. You need to get the wood to create the charcoal in the first place. So again, there's a vicious cycle there where you can see that you've got waste disposal burning, creating CO2. You've got charcoal burning, creating CO2 as well. And finally, it's water hyacinth. Now, this is where I sort of do my Max Bygraves bit and say, I want to tell you a story. Many of you have probably seen water hyacinth before. It's an aquatic plant. If you walk around some of the National Trust properties, if you've been around, certainly in Indonesia and places, you'll see it all around ornamental ponds. It lives in fresh water. Lake Victoria is fresh water, so actually it's got a nice place to live. It's classified as an alien invasive plant, not just in Lake Victoria, but across the sub-Saharan and equatorial regions. It's actually outlawed in Kenya, believe it or not. It can double, if it's left unchecked, it can double in mass every 20 days. Okay, so, and the seeds, if you just throw them away, actually can lie dormant for up to 20 years. So in a nutshell, that, as it says, once you've got water hyacinth in your environment, it's highly unlikely that you're going to be able to totally eradicate it. That's interesting. Kisumu, as I said, where we're operating, in this heat map, you can see straight away that actually it's a big problem in that area. But that heat map there shows you where water hyacinth is prevalent across the world. Mainly sub-Saharan. So why is it a problem? I've already explained that it can double in mass and so on and so forth. The weed itself floats on the water. It's about a metre and a half, bit below, bit above. And it floats, it comes together with the wind, the weather, it blows up into inlets, and it forms big weed beds. So two problems there. One is you can't get around to fish because you've got all these weed beds. And the second thing is the fish are clever. They hide under the weed bed. So you can't get them anyway. So the fishing industry around the lakeside, which is one of the key employers and the key food supplies of the area, is actually blighted by this. In some ways, it also acts as a filter. All the pollutants that come into Lake Victoria from all the various industries, actually the water hyacinth does collect those pollutants and actually does sort of cleanse the water in some ways. But it also harbours many of the diseases, certainly the ones that are very prevalent in Africa. And anybody going into the water to try and clear their weed actually runs the risk, if they're not adequately protected, of being exposed to potential harmful diseases. As I say, it blocks harbours, lakes, rivers and canals. And it really does block it. Tourism, transport, the lake is used to move goods and industry, goods and products across the lake between all the various the countries. Water hyacinth blocks a lot of the waterways, which means that for almost half the year you can't run boats up and down some of the waterways because it is completely blocked. And where you've got a river or a lake which is feeding a hydropower station, if you don't control your water hyacinth, it will block the source of water into the power station, the hydropower, contributing to again, the power outages on the Kenya grid. So, huge negative in economic and social impact in this area, and indeed all around the Lake Victoria Basin and in other parts of the country where water hyacinth is a pain. Just to sort of try and give you a sort of scale of the problem, if you look at that picture there, so Kisumu at the top, what you're seeing there is a nice little boat there along a jetty. Over there is the government-owned rice mill. The distance is 2 miles. That's all water hyacinth. And that's the main, that jetty is literally about here somewhere, and the rice mill is over there. So you can see it's blocked completely the estuary into what effectively is Kisumu Port. A 1 hectare weed bed at a low density, in other words, if it's a young virgin weed bed that's just happened to collect it up, probably if you pulled all that weed out of the water, and water hyacinth is 93% water. So if you pull it out onto land, you're probably going to get about 400 tons of volume, of weight. If it's been there for a long time, and it's been pushed in by the wind and the waves, and it's got very dense, then it could be 500 or more tons in terms of the actual sort of weight that you're trying to drag out of the lake. At its peak, and this is a few years back, and we're talking very much the Wynnum Gulf area, we're not talking about the whole of Lake Victoria, the Wynnum Gulf, and it was 17,000 hectares, measured at 17,000 hectares. Density was clearly not known because they're looking at it from satellite imaging. On average, it's about 9,000 hectares of weed in that area. And if you want to know what 9,000 hectares of weed actually looks like, it's about 20,000 football fields. So that's the scale of the problem that is in that particular area. But every bad story, has a good ending, or a potentially good ending. Actually, water hyacinth, you can process it. You can process it and turn it into a biogas, or you can process it and turn it into a biomass. Actually, if you process it a different way, you can turn it into briquettes, which you can then burn. And the calorific value, the heat value, the cooking value of those briquettes is roughly the same as charcoal. So you can sort of see already that actually there's a potential to replace some of the charcoal usage. And many of you probably have been around B&Q, all the garden centres, and you've probably seen, when you're looking for your conservatory and your patio furniture, the sort of reed mat furniture made up of woven reeds. If you lift it up, look behind it, it says Indonesia. Generally, that's water hyacinth that's been turned into a weed mat that they then basically plaited together and turned into chairs and furniture. So, half empty, half full. Is it a problem, or is it a resource? Bit of the marketing bit now. Okay, Aquatractor. Clues a bit in the name. We are actually a start-up company. I'll make no bones about that. We are new as a team, quite a largish team, but we're new. But we're not new to doing the work. We actually have come from a pedigree. I came from my allotment, by the way, but we've come from a pedigree of experience in the aquatic industry and experience in the farm machinery, agricultural business. Our main experiences within this, we've got over 25 years of water management and using what effectively is a waterborne tractor to go and collect weeds around the canals of the UK and a lot of private waterways around England. In fact, one of our Aquatractors was used, or was on standby, for the Olympics to clear any of the weeds in the Olympic Park. And there's one currently running up and down a couple of the canals, clearing the weed to keep the canals clear. We have one of our team who has spent over 25 years as the MD of a major machinery manufacturer who were doing the design of our Mark 1 Aquatractor, the basic small ones we use in the UK. We have somebody who's got vast experience of electricity generation and distribution in areas such as Afghanistan and Iraq. You can guess he's ex-military engineer, but more importantly, we're also teamed with a company that is big into anaerobic digestion and generating power from that. So we've got somebody who has been on the ground, boots on the ground, done the work, set up the infrastructures, and the team behind us that enable us to help us with the design and the manufacture of the equipment. And then down the rest of the line, project planning, key person has got a lot of experience working with Africa, non-government organisations, and understanding how you do business in this environment. Okay, what's our vision? Actually, we don't see it as a problem. We actually see it as an opportunity. And as examples there in the photographs, Block Lake power station, waterways, and the one I showed you earlier about Kisumu. We intend to be the first project in Africa that will maximise the benefits of collecting the weed and indeed the waste and generating it into power. Power will then be fed back in to the grid or wherever, but creating power. That is a commercial venture. I'll make no bones about that. That's a commercial venture. But in doing that and in delivering that commercial venture, we will also provide employment, but more importantly, we will enable that community, that area, to regenerate. We will be able to bring back the fishing. We should be able to reduce the amount of charcoal that's being burnt. Tourism all around the beaches, there's an enormous amount of good that can be done by that one operation. Ideally, the solution is scalable, up or down, so therefore it can be rolled out around the Lake Victoria Basin to other countries, and indeed it has the ability to be run across the world to wherever there are problems with water hyacinth and waste, where this solution would be ideal. I would guess going into Indonesia, where they've got a very thriving furniture business, if we rocked them on a doorstep and started nicking it all and shoving it in and creating power, wouldn't be very happy. But that's... So, in a nutshell, we believe that we could be a force for good in Africa. Now, big, fluffy words, that. Force for good, how big, how small, don't know, but we can make a change, we can make a difference, and I think that's the important thing that I'd like to get across on this. The project. What are we doing? Okay, the first part of the project, although I've spoken very heavily about water hyacinth, the first part of the project is actually to put 2 1-megawatt anaerobic digestion plants on the lakeshore, and we'll be feeding those 2 plants with the waste material, land-based waste material. In other words, we'll be setting up, if you like, the commercial venture, which says this is a business which actually can create power and it can solve some of your problems. For those of you who probably don't know much about anaerobic digestion, I won't go into the big details, but if you think of your compost bin, where you throw your waste, you put a lid on it, or you put a bit of carpet over it, and over time it rots away and you get that nice black stuff that you throw in your garden. Anaerobic digestion is a very similar principle to that, but what you do here is you take the waste, you make it into a slurry, you put it into a big storage tank, which is sealed to the atmosphere, there's no air in there, and you add some bacteria, you whiz it around, and after a certain amount of days, the bacteria digest the waste and create methane gas, and also they create a residue that, once dried, is effectively a soil enhancer. So the gas is then taken and it's used to power what we call a combined heat and power unit. It's a big gas turbine or a big turbine. It will generate electricity. That electricity is then fed into the grid, or it is used to a specific user, and the digestate itself is sold off as a sort of a low-level fertilizer. It's not a fertilizer in the sense of the big expensive stuff and the guarantee to make your plants grow X big. It's a sort of a soil enhancer. The heat that's produced by the combined heat and power unit Some of the heat will go back into the digestion plant, because actually the hotter you get the mix, the better it's digestive, it works more efficiently. And the excess heat, currently we're looking at obviously heating the buildings which we will have there, but also possibly running chillers for the fishermen to be able to store their fish that they bring off the lakeside, and therefore can keep their fish fresher. So having multiple banks of chillers on the site that they can come and use. In parallel, but slightly behind, we will be starting the clearance operation on Lake Victoria. We have staggered it for two reasons. One is that there are a lot of political implications around what we're trying to achieve there. Political in the sense of weed ownership and exactly who owns the weed, and what bits of land are we going to be using, and does it owned by the government, not owned by the government. So there's a whole lot of aspects around that, which means that it's quite high risk at the moment, but not insurmountable. So by establishing the first stage, which says we've got an outlet for the weed, then we hope that will give greater confidence to the authorities to say, yeah, go ahead and do it. And finally, which is quite downstream, but it's sort of almost a logical link to where we're going. As I said before, you're not going to eradicate the weed from the lake. What you're actually going to do, probably at the end of the day, is manage it. Manage the weed, manage where it is, to ensure that all the employment that was there before the weed was there can actually be regenerated. For that, you're naturally going to become a bit of an expert in water management. So it's not a huge leap to say if we team up with a university or a college, we could create a centre of excellence for water management, which then could be spread across the area. Business model. So I've just given it to you in words. This is it in pictures. Bottom left, we start with the waste. Municipal waste, bagasse, rice husks, all gets sorted, all gets mixed into a slurry, fed into the digestion plant. The output from the digestion plant goes into the power unit. The electricity generated goes out. We sell the electricity to either Kenya Power or to another supplier. The residue, becomes a soil enhancer, which again we will sell. Now, one of the ways we're looking at this is we're not out to make billions and billions and billions of pounds. It's a commercial venture, but it's also about making that change. So the price that the soil enhancer will be sold to the local people will be commensurate with what we're trying to achieve. Because actually, arguably, it's a bit of a waste product in some respects. So actually, it's going to be there. We can move it on. There's no point in putting the price of the soil enhancer at the same price as the fertilizer, because they can't afford the fertilizer. They're not going to afford the soil enhancer. So, but it's a revenue stream. Phase 2, stage 2, is actually this, clearing the lakes. Now, we expect that we would be paid to clear the lakes, because actually it's such a big problem that in order to be able to ramp up and indeed have the sort of capital equipment expenditure, we would need to ensure that we're going to make a return on that expenditure. But what we'll be doing, these are our current little Mark I Aquatractors, no good on Lake Victoria, out in the sort of 2 kilometres out, quite useful around the sort of the edges. So we've got a new version in design at this moment in time, in design and manufacture, and it will be much bigger. It'll be seaworthy, because actually, if you think of Lake Victoria, it's like being out in the ocean. So it's got to have all the sort of safeguards and safety you'd expect to see on any boat that would be going at that sort of distance. But what we would do, we would, using a fleet of aquatractors, collect the weed. The weed would then be deposited onto what we call an intermediate support vehicle, an ISV, what that does is acts as a holding point for the weed. It then macerates the weed. I go back to saying that the weed is 93% water, so when you macerate it, it creates a bit of a slurry. And we will use that slurry effect to pump it on these floating pipelines. So if we were to just drag the weed all the way back, say 2 kilometres back to base, we're carrying all that excess water that we don't actually need. If we macerate it at the point of collection, we can use that water to pump it back to shore. So the idea, we pump it back to shore to a storage tank at shore, inshore. And that basically is the project and the way that the business sort of model works. And that. Simulation. Where does simulation fit into all this? Why have we chosen to use simulation? Credibility. This is, you know, as I said, we are a startup company. We've got plenty of experience in the technology that we want to use. The technology that we want to use is not rocket science. It's actually out there today. It's being used all over the world. Digestion plants, tractors, collecting, and that stuff. So we're happy that we can talk about what we want to do. But many people and millions of dollars have already been pumped into tackling the water hyacinth problem on Lake Victoria. They've not solved it, and they've not solved it for a number of reasons, but primarily they've not solved it because actually they looked at it purely as, let's get rid of the weed. They haven't looked at it and saying, I've now got the weed, what am I going to do with it? So many of the attempts that have gone on, they've basically taken the weed off the lake, parked it on the shore side where it's rotted, it's stunk, or it's found its way back into the lake again. It hasn't actually made a difference. So to many of the people we're going to see, and we're not talking about venture capitalists and that sort of thing, we're talking about the sort of charitable foundations, the Aga Khan Foundation, the African Enterprise Challenge Trust, all these people who have got grant money, the World Bank have got grant money to try and tackle the problems that are abound in Africa and other developing countries. We have to front up to them and say, actually, we know what we're doing here, guys, you know, and we have a solution which we think you would be interested in. We see it working in 3 distinct areas. First of all, in the investment phase, the phase we're in at the moment. We then, oh, that was quick, then it will go steady state operations. We're up and running, we're going to get some data, we're going to be able to optimize and look at the way we do business and change things, improve things, start looking at cost avoidance. And finally, in the future business side, where we'll be able to look at emerging markets and actually use simulation modeling to find and sort out the best way of doing business. If I go back to the investment phase, there's 2 bits there that the modeling works in my view. The first one is we've had to create a business plan. Part of the business plan is how much is it all going to cost us? Well, you know, we can do that. We can say, I want 4 tractors, I want a bit of this, bit of that, and then we come up with a big shopping bill that says it's going to cost this amount of money. We go to our first set of investors or our first set of charitables, and they just say, so how did you come up with those figures? Actually, by creating a basic, fairly basic simulation model, we've been able to explain why we've arrived at certain decisions in terms of the quantities of the equipment that we are proposing to put in place to tackle the first stage. Now, this is purely about water hyacinth clearing. The bit about producing electricity from landfill waste doesn't need any modelling today because actually that's a fairly straightforward, we've got a source of supply, we know what we need. This is about actually how can we take the weed off the lake in the most sensible, cost-effective and efficient way to meet the needs of ourselves and clearly the people in the area, certainly the governments in the area who want to try and clear this lake. So we have created a very simple, and I will say it's a very, very simple witness model. It has used a bit of Excel in it because Jeff helped me out on that one. So it's, but what it's basically looking at is this particular simulation is just showing there's a weed bed, there's a tractor, it shuttles backwards and forwards to the support vehicle, which then processes the weed and pumps it to a storage depot. Very simple. That's it. However, in coming up with that model, there are a number of factors that we need to consider, and they're listed down the side there. So how much do I actually want per day to power my digestion plant? How much have I actually got to pull off the lake? What sort of weather am I going to encounter during the seasons? And how does that actually affect the way in which the performance of the vehicles? What distance are we operating from the shore to the ISV or just close in? Density of the weed bed. You know, are we going to be cutting one that's 2 or 3 years old? Are we going to be cutting one that's this season's growth? Again, that will determine how quickly the tractor will work in that case. Breakdowns, cleaning, all those factors. We need to be thinking of those, and we've included some representative figures within the model, either as a variable, as a triangle, or as a discrete factor, such that when we present our pitch, so to speak, we're able to show the potential investors and to show the charities that we're working with that we do understand what the problem is. And if I go on to the next picture here, you can see the little red highlight there, which basically just shows that there's a breakdown. When you run the model, it runs so fast, you know, that, to be honest, if you're showing that to an audience, they'll be going, yeah, right, what happened? So by stepping through it, you can show how you've brought in these various influences going through. So we will step through the model if required. We will show it in different ways, depending how they want to see it. Here it is. It's completely finished. Its cycle. It's collected 400 tons, and it's taken 23 hours. And that's with the current set of data that we've put in there. Now, we have a master data list, master data assumption list. Much of it today is theoretical data, the performance of the Aquatractor Mark II. We haven't got one on the lake using it, so we don't know. We know what it should be capable of because we're using our Mark I and taking it and scaling it up. So some data actually is validated. We already know that it is real, sound, solid data. Others clearly are sort of theoretical. But basically, with what we've created, 400 tons, 23 hours, continuous operation, including breakdowns and cleaning. Actually, when we sat down before we had the model, and we did a bit of sort of longhand multiplication and division, we came up to roughly around that sort of period. So it's given us a bit of confidence that, you know, having spent sort of, you know, a week of brainstorming and that, we've actually come to a sort of figure that broadly we're quite content with. We've adapted the model to show 2 tractors, and therefore how that's clearly the time will come down. And that at this moment in time is where we are, and it is sufficient to have enabled us to understand broadly how much equipment we need in sort of rough handfuls with a degree of accuracy, and to convince the people, the audience that we're talking to, that we're not too bad. We do have an idea here, and it's worth pursuing. From a modelling perspective, the next steps, we want to create some additional models, because this model, the pipeline model, only really works for a reasonable distance from the shore out. If you imagine having a 10-kilometre floating pipeline on Lake Victoria, it's going to cause a bit of a problem to any passing ships and that sort of stuff, and also the pumping and that. So it works to a certain distance. So we now need to be thinking about other ways of bringing the weed ashore. One way is to just cut it, put it into massive big barges, pulling it ashore. Another way is actually macerating it into a slurry and then sending it ashore. So we need to be thinking about how we would do that as we gradually get further out from the lakeshore to where the weed beds are. We plan to have a trial. We're currently trialling in the UK on our Aquatractor ones, which basically is validating some of the data we've already got. We plan to have an Aquatractor Mark II, ideally by the end of next year, out on Lake Victoria, trundling up and down, giving rides to the local dignitaries and that sort of stuff. That will give us some real-time data on the performance of the Aquatractor. Bearing in mind I said that the project is in 2 stages. The first stage of the anaerobic digestion plant, etc., assuming the funding comes through, which we're fingers crossed, will be next year. We start weed clearing the year after. So we're talking about a 12-month. And then as we get out there, as we start doing the business, we'll be looking for new markets. We'll be looking to use the models to make sure that we continually are looking at the way we're doing it and looking for improvements, looking for ways to ensure that we don't waste money on unnecessary expenditure on equipment. Where are we now? I talked about credibility. I talked about being able to confidently convince somebody that we are worth thinking about. Those 3 things there, those 3 activities, were part of our submission to the African Enterprise Challenge Fund. It's a World Bank administered fund. There were over 300 applicants for grants. We got down to 27. We then had to go to Kenya. I didn't go, not that I wanted to in that particular time. And they had to give a very short, sharp, 7-minute presentation on why the AECF should invest in ourselves. They'd already seen our business plan. They'd been into the UK to do due diligence on us. They've already seen the model. We took them through the model. We showed them what we were doing. We explained to them what we were doing. At the end of the day, they were only going to take half of the applicants. And we were successful, scratched the surface to what we want to do. But what it does do, it brings us credibility. The African Enterprise Challenge Fund have seen our project as something which is worth investing in. Very interesting that no sooner had we been given notification that we had been awarded this grant, the emails and phone calls came in from the likes of a number of venture capitalists, but also a number of other charities, saying, you know, we're doing this, and indeed industries that have what they call corporate social responsibility. You know, we are a classic. If somebody wants to sort their corporate social responsibility issues out, come to us. We could give them a complete project which will help them in that way. So we're suddenly, our phone and email is starting to block up with people wanting to talk to us. Andrew Cranfield, our MD, is today up in London talking with a number of agencies. DFID, which is the UK arm of the development, regularly ring up and say, any chance you can come and give a chat about your project to this seminar, to this meeting. And 2 weeks ago, the Permanent Secretary to the Kenyan Prime Minister was in the UK and asked specifically, would Aquatractor come up and talk to him about the progress we're making on the project. So it's giving us leverage and credibility, and that's worth a lot more. We have an application in with the Dutch Sustainable Water Fund. It's interesting that throughout Europe, there are a lot of countries who are wanting to invest in Africa, charitable foundations wanting to invest in Africa, wanting to help Africa to develop. As I said earlier on, our weed harvester is in design. It's in, and we hope to have it out to test in the not too distant future. In summary, I said at the beginning, power, waste, agricultural costs, fishing. I hope that you can see that what we're about will help. It won't solve their power problems, but it will certainly help in the Kisumu area, bring some stability to the grid. Clearly, the farmers, in being able to provide them with some soil enhancer, will help them with their agriculture. The fishermen, the tourists, will be there. They will benefit greatly from the fact that we can control and clear the weeds. We will have excess capacity water hyacinth, because we have two feedstocks, land-based and water-based. Therefore, we have the ability to use some of the water hyacinth for briquette making. And in that end, what we would plan to do there is actually give the water hyacinth free of charge and allow micro-businesses to set up, creating briquettes to be sold around by generally the women. Generally the women in the area do those sort of things, little micro-businesses. Get them a briquette making, we'll give them a briquette making machine, they'll get a supply of water hyacinth, they'll dry it out, they'll turn it to briquettes, they'll use some for themselves, and they'll sell it around. Ultimately, we will make a difference. It might be a small difference, it could be a huge difference, but I think it will be making a difference. So what I'd like to do now is just leave you with a very short video. It hasn't got any music to it, for two reasons. One is, I couldn't put it on, hand up. But having sort of watched it, I think not having the music allows you to look at the pictures and allows you to think about the difference that we could make with this project.